This is Mr. Premjit Vasudevan, sir. He's a chartered structural engineer and consultant, and he has been working in this particular field for more than 20 years. He has got a keen expertise in various fields like buildings, which includes apartments, hotels, community centers, IT parks, etc. Along with that, he is well versed in the design and analysis of various infrastructure facilities like rails, underground rail links, etc. So we had a very good resource person to introduce us the particular tool Revit for the analysis and design of building and the building information modeling. So I think Sir will be enlightening us with a particular software, and many of us are new to this particular software. So kindly, Sir, you can start, sir. Thank you for your spending the time with us.
Yeah, thank you. Thank you for the introduction, Anita.
Yes, sir.
So let me quickly tell you what Revit can do and what it cannot do and what is building information modeling, all that. So I'll share my screen first. So many beginners ask me this question. So I'll start with that. What do you mean by BIM? So building information modeling, the short form of that is what we call as BIM. And many students and many beginners ask me, what is the difference between BIM and Revit? Is Revit BIM? Is BIM Revit? There are so many questions like that I get. So let me tell you what BIM is and what Revit is. What is the difference between that? Now, simply put, BIM is a process and Revit is a tool to achieve this process. That's a basic difference, which means that building information modeling is a process and Revit we use to achieve that process. In a simpler way, even AutoCAD, yeah, we say whenever we want to produce a drawing, we say that, okay, let's make an AutoCAD drawing. But AutoCAD is only one among the many tools under CAD. There are many other CAD tools like ZWCAD, StarCAD, but we know them lesser. We know more of AutoCAD because that's more popular. It's an Autodesk product. And we achieve CADing using AutoCAD. The same way, we use Revit to achieve building information modeling. So that's the basic difference between BIM and Revit. So there are many other products like Revit which can be used for achieving BIM. Now it depends on the tool that we use. Say Revit is one among them. Then you have EcoSim from Bentley. Then you have Tekla. There are many other products. So these are the three main products now more popular, and most popular in building sector is Revit. So Revit is an Autodesk product, so it's more popular, of course, and we use Revit to achieve building information modeling. The same way, you can use EcoSim or Tekla also to achieve BIM. But what you can do and what particular tool each BIM tool has differs based on what Autodesk has included in Revit and what Tekla, Trimble has included in Tekla, and so on. So these are all tools to achieve a process. Now, what is this process? This process is nothing but a complete difference from what we do right now. See, for example, maybe 2 generations before or 1 generation before, we used drawing board for producing drawings. Yeah, then there was a big shift from normal drawing production when CAD came into picture. It revolutionized the way we work. Many things changed. Yeah, the number of people that we need, so many things changed in that manner. So the same way, the process of BIM or Revit, the tools that we are going to use are going to change the way that we are going to work. It's more of 3D modeling. It's not anymore CADing. It's not anymore a CAD work. It's not anymore a isolated drawing production. It's a complete information modeling. What I mean is, based on your skill and based on what that particular tool, in this case Revit, allows you to do, you can even 100% accurately model everything. In the sense, if you are an architect, you can even model a geyser inside a bathroom. You can even model a switch, the particular switch. Many of the manufacturers have started producing Revit files for their products. So you can incorporate the exact material finish, the exact equipment that you are using, the exact materials that we are using, and so on. So the level to which we can have the accuracy depends on the tool and your skill and the time involved and things like that. But more or less, Revit allows you to do a perfect modeling in terms of any discipline. It could be architecture, it could be structures, it could be MEP, or anything. Even a very high level of Revit allows you to do even construction and construction documents and even quantification and so many other things in Revit. So it's a elaborate process. There are many levels of BIM that we can achieve. So the basic difference in this process would be, I will just explain with a bit of slides. So you can have real life information in that. That's what I just now mentioned. That is, you can model rebars, you can model footings, you can model anything that you want as a structural or a civil engineer, and you can also model to a finer detail, even the brick layers, even the finished layers, anything you want, even the painting style and everything in Revit if you are an architect or an interior designer or whichever discipline you belong to. So that is one main advantage, real life information that you can include in it. So a CAD drawing may not be able to convey everything in the exact manner that you may want to. Then a major difference is its parametric behavior. Now, when I say parametric behavior, in CAD drawing, in CAD system, the way we currently work, if you produce a plan and then say we made a section of a part section or something in that drawing. Now, if the plan changes, then the section also you have to revise. I will just show in Revit itself what I'm talking about. So this is a Revit model that I have already made, a little larger building, not a very large building. And this is a 3D model that we make in Revit. I will take you through some of the steps after I explain this. Now, if this is the plan of your building, and say if you draw a section somewhere here, and say if this beam depth changes, now you have to revise the plan drawing as well as a section drawing when it comes to AutoCAD system of working. Now there are two problems in that. One is that you can make a mistake. You can forget to change the section. Your revision was reflected only in the plan, whereas you missed to revise the section. That's a human error. There is a possibility that. Second thing is that you will take more time to revise this. You have to revise the plan. You have to revise the section. So there are two drawings that you need to revise. And handling of that drawing, you have to print it. All that is there anyways. But in this case, if you revise in plan, it's a 3D model that you are revising. So when you revise in one place, it gets reflected everywhere. So that is one beauty, and that is what we call as parametric behavior. So let me try to show you that. Let's say top of footings I will take here. Now, if you want a section here, it's only a matter of taking a section and drawing it here. So I'll draw a section here. Now in AutoCAD, you will have to draw this, whereas in Revit, it is automatically produced. And if you look here, your section is automatically produced here. So there is no work involved here. You are automatically doing that. In the sense, there is no need of producing a section. It's automatically generated for you because it's a 3D model and it's parametric. So that's one advantage. So now in case if I delete this, say I delete this column, I mean footing, and you can see that it's reflected in the a model automatic. So there is no need for you to revise this particular drawing because it's already done in plan. It will get reflected in the section. It's the same way. So the quantities, if you have taken out, you can even take quantities in Revit. So if you have done all this, automatically everything will, all the interconnected things will change automatic. The same way, if imagine that you have a RC wall here, say in this location, under this beam, you have an RC wall. The moment you make this beam shallower, say the depth you reduce, the height of the wall increases. The same way, when you increase the depth of the beam, the height of the wall reduces. So it's parametric, it's interlinked and it's interconnected so that you need not revise quantities or related drawings manifold. So this is what we call as parametric behavior of Revit, which is quite advantageous for our way of work. Then work sharing and collaboration. These are underestimated advantages of Revit, where many of the beginners or many of the normal consultants or normal trainees will never will be appreciating and telling you about this. This is something which you need to understand really well. Work sharing means in AutoCAD, you might be knowing about layer system, wherein you can have different layers for say drawing different components. Say one layer you use for beams, one layer you use for drawing. I'm assuming that you will be knowing AutoCAD. So the layering system, the same way in Revit, Autodesk has taken it one step forward, and then they have given an option to layer users. In the sense, I can be a part of a team, you can also be a part of a team, and 10 others can be a part of a team, and 10 people can draw in 10 different places, sitting in 10 different places, 10 different things in the same plan, and all that can be collated together and made a drawing. So you can share your work. Say it could be even in same floor, or it could be even in multiple floors. Say if it's a 10-floor building, you can say that I will draw the first floor beams and someone else will draw the column layout and things like that. So at the end of the day, you can collate information, interlink them. 10 users files can be interlinked and made it into a single model at one place. And you can be in US, you can be in India, you can be in different places as well. It depends on your bandwidth. That's a different aspect altogether, but Revit allows you to do that. So that's work sharing. The same way you have collaboration, in the sense different disciplines. You know that if it's a large project, there are many consultants involved, an architect, a structural engineer, a MEP consultant, and so on. So everyone's work can be shared like this and then interlinked. So if you make a revision, or if you see an architect moving a wall, and if you know that that change in that particular wall into some place will affect your drawing, immediately you will be able to understand that. There is no need of a coordination meeting, or you wait for getting his drawing and then see overlay and see if anything is affected and things like that. So immediately you can pick up the phone and tell him that this change is going to affect your drawing and so on. So the collaboration or the coordination part will be super fast, and the abortive work, the kind of revisions that you might have to do, will be much lesser. So that's what collaboration allows. We may not have time to get into work sharing and collaboration today, because also we will need a networked machine to explain all that. So I may not be able to explain this process today. Then scheduling, you can create tabular display of model, in the sense you can take out quantities. Then interoperability means you can import, export, and link things. For example, you can interlink an AutoCAD file. Say architect has made the drawing in AutoCAD and you want to draw in Revit. You can do that. You can overlay on AutoCAD and produce your Revit modeling. The same way you can export the drawing, import the drawing, you can make it into CAD formats and take your prints. If you want to have conventional CAD drawing, you can still do that from Revit. You can take that. You can also interlink analysis tools and Revit. You can interlink ETABS and Revit, or you can even interlink Robot, which is another analysis tool, into Revit and then work together. You can also create a lot of annotation text and everything quite fast, which I might be able to show you today. So these are the advantages of Revit or any building information modeling tool for that matter. Again, depends on tool to tool. There will be slight differences.
ജനൽ അടച്ചേക്കണേ.
ദക്ഷിണ മേഖല കർഷക അത്തല്ലൊരിക്ക് നൽകില്ല. മാസ്ക് ധരിക്കുന്നത് പ്രോത്സാഹിപ്പിക്കുകയാണ്.
Excuse me, sir. Can you mute and mute all and unmute yourself?
Mask is the mask.
Okay, so coming back to Revit model, many might have another question, that is, what is the difference between Revit architecture, Revit structures? Some of you might have heard about Revit structures, Revit architecture, Revit MEP. Yeah, there is no much difference between Revit architecture, Revit structures, or any Revit discipline for that matter. Earlier days, when Revit was becoming popular, when they launched initially, there were 3 different software, but not anymore. All these are under one single software called Revit, Autodesk Revit. Now, even AutoCAD, we will never ask, is it AutoCAD civil or AutoCAD architecture? We draw lines in architecture or in structures or in any discipline. You draw lines or whatever tools AutoCAD gives you, you draw that using those tools. If an architect use it, it becomes an architectural drawing. If a structural engineer use it, it becomes a structural drawing. That's it when it comes to AutoCAD. The same way, the same things in Revit also. You have Revit structures. If you look here, there is a ribbon here. So here, if you go, you get all the modeling components that is useful for structural modeling. So you can see beam, you can see structural wall, you can see columns, you can see truss, you can see wall, things like that. The same way, you will have an architectural tab here in the ribbon. If you see here at the top, if you go to architecture, you can see things that suits architects. So you have door, you have windows. Some components like column, wall are common for all of us. So it'll be there in both the disciplines. So this is the main difference. The way we work, or the methods and techniques and the interfaces all remains almost same. Only thing is, you may have to additionally look into how a door can be placed and things like that. Otherwise, Revit architecture, Revit structures doesn't differ much, but how much architecture you know allows you to draw more of architecture. So if you are a civil person or a structural person, concentrate on Revit structures or modeling using the structural components. If you are more into architecture, you might be using more of architectural tools. If you are doing both, then you can switch around between the 2 apps and get whatever you want. So that's how it is. I hope it's clear. Now, coming to Revit, I will open a new file and then try to familiarize you with some of the tools and then take you through some of the things possible in the limited time. I cannot get into micro things, so a macro level modeling I will show you right now. So I'm going to new, as in any software, new, and I'm going to click on new project. Now it will ask you templates. Yeah, so you need to have a template loaded. So Revit gives you a lot of standard inbuilt templates, which is good enough for a beginner. And for most of the normal building modeling, this would suffice. So here you can see structural template. So based on which discipline you are going to, you can use that particular discipline template. So structural template is what I'm going to use now. So the moment I say structural template, it asks you if you want to create a project or a new template. So I'm saying it's a project and then say, okay. So it opens up the new project. Now, this area is called a ribbon. And then you have a lot of toolbars here. And then you have a properties palette here. And you have a project browser here. So this project browser, this properties palette, they are very much important. They are essence of Revit. You need to do a lot of things here to navigate and to scroll and to go at many places. These two are very much needed, and this ribbon, of course, is very much needed. So if you look here, this project browser gives you the information that you have in this file right now. So it shows you everything this particular file has, this template has. So if you look here, you have two levels. You can see here level 1 and level 2. So there are only two levels in this particular model. And then you have 4 elevations. Then if you look here, number of sheets, the drawing sheets here. If you go to families, there are a lot of things here like beams, columns, all that. So before that, I will tell you something about the hierarchy concept in Revit and then get into that. So if you come here, in Revit, there is a hierarchy. So at the bottom of your pyramid, you have type. And at the top of the pyramid, you have category. So we'll start with category. So as I said, Revit is a modeling tool. So there is nothing called drawing here. It's all modeling. It's all 3D modeling. So a category means anything that we model. So it could be a beam, it could be a wall, it could be a window, it could be a foundation, it could be anything like that, a modeling category. Next comes family. Now what is family? A split or a division of that category, say RC beam, then say steel beam. So that is family. So RC beam is a family of category beams. Steel beam is also a category family of category beam. Same way, walls could be RC wall, brick wall. So brick wall and RC walls are families, and wall is a category. That way, everything is categorized and there will be a family under that. Then comes the specific type. So for example, if you have a RC beam, beam is the category, RC beam is the family, and 300 by 450 is a type, 300 by 600 is another type. So any element, any modeling element has a hierarchy like this. So by using it for some days, you will be automatically understanding all this. It's not a complicated stuff at all, but everything has a system and a process. So you need to understand that. Once you understand that, it's going to be really simple for you. So category, family, and type. The same way, there are different kinds of categories. In the sense, I'll explain it to you. There are model elements. Model elements means real life elements. So it could be a beam, it could be a column, it could be a footing. Anything that you really see in sight is a model element or a real life element. Datum element means it's not really there in your building, but you use for reference. Say something like a level that you mark, a grid that you mark. You need that in model, but you don't. You need it in site also, but then you don't need it in your building. It's only facilitating the construction. It's not a model there. So such elements are called datum elements. Yeah, level, grids, all that. Then comes view elements. An example is drawing sheet. Drawing sheet you don't see in site. In the sense, you will be printing a sheet and then giving it to a site engineer. But once the building is done, you don't have a sheet in the building. So that's what view element is. Now view specific element means your text, your dimensions, your annotations, anything that you mark in your drawing. Again, that's not there in your building. It's used in the drawing, but it's not present in your building as such. So 4 element model, which is real life, datum, view elements, and view specific elements. So with this, we'll go back to the model. And then if you come to your project browser, you will see all the categories here. Any category that is loaded in this particular file is seen here. So there are many things which are necessary for us. Pipes and all that is not necessary for us. You have beam systems, you have column systems, and if you go inside column system, you see concrete rectangular, you have B column, so many types are there. So this is your category family, and if you go here, you see the types. So that's how you can understand. So in this project browser, whatever you need to model in this project should be there. If it's not there, you need to bring it here. All that we don't have time to do it today, but then that's how it is. Now, let me first get into level and then show you, sorry, elevation and then show you. I'm going to east elevation. So just in the browser, I'm clicking on east or anything. Yeah, so you have two levels. So here you can see level 1, here you can see level 2. So what I will do is, I will reduce this height. Let us assume that this is your foundation top and this is your plinth level. So let me assume that it's 1500 or something like that. So here, the moment I clicked here, it showed me the distance. Here it's in meters because it's level. Generally, levels are marked in meter. Anything is fine. It can be millimeters also. And here you can see 3000. So here I can click and then say 1500. It's coming down to 1500. Now, the beauty of this is, now say you are more proficient in meters and not in millimeter. You can just type 1.5 m. It does the same thing. Now say you are familiar with feet and inches, not with millimeter and meter, not SI system. You are more familiar with feet and inches. You can say 10 feet. It does the same thing. So that's how this works. You can use any units, but the preset in this case is millimeters, so it's displaying millimeters. But you can work in any thing. So I'll make it 1500. So it comes down to this. Say I want one more level. So let me go to structures, and then you can see here level. Now another thing is, the moment you move your cursor, you can see that it grips. So here you can see it automatically picks that endpoint. So your drawing will be automatically neat. No need of trimming and all that, because it's picking the endpoint by itself. And you can also see the distance rolling up there. So 1700, 1900, you can adjust, or you can type whatever distance you want. You can type, say, 3000 millimeter, then it will be picking 3000, or you can scroll and pick the distance that you want. Another beauty is, Revit is built based on AutoCAD user experience. See, for example, one example I'm showing you. See, 3700. Now when I move, the distances are changing in hundreds. 4100, 4200, 4300. Now see, if I zoom, or let me zoom out. Now see, the increment changed. So the moment you are away from the screen, Revit automatically understands that you are looking for lesser accuracy. When you come near, Revit automatically understands that you are looking for more accuracy. So it automatically adjusts the increments. You can set that increments, which I will show you later if we have time, but these are all micro things. I'm only covering the macro things today. So that's the beauty of Revit. It appreciates the user experience, and it is evolved from AutoCAD users' feedback. Now I will pick 3000 here and draw that. And at the other end also it picks that. So let us draw maybe one more level. Yes, so this many levels are fine right now. And then let me go to level 1 now and draw some grids. I'll be a little fast now because we are running out of time. The same thing, the way we did for grids works for levels, will work for grids also the same way. So I'm going to draw in 5 meters. I'm drawing some grids, say One more. And you see it will continue the naming 1, 2, 3, 4, and 5. So if you want to start afresh from A, you can change here A, the next one will come as B. I'm not showing that now because we are running out of time. So it will be continuous like this. You can pull this and keep it in a, so when you pull one, everything will get pulled together. So that's another beauty. So here now level 1, we are in level 1 and we have up to 4th level. So I'm going to quickly draw some columns here. I'm not caring what size, I'm just going to pick some columns. So here you have the column tab. The moment you click on it, it'll ask you what kind of column you want. You want steel or you want concrete. So I'm going to choose 300 by 450 column. The moment I click on 300 by 450, it will ask you, do you want to rotate it? If you want to rotate the column, you can do it here. And it will also ask you from where to where. So here I'm going to say, we are in first level now. So I will say not depth, but height, because we want it from first to fourth. And then say 4. And there are various ways that you can do it. I'm going to show you a simpler way, add grids. So I'm going to choose add grids. And in one shot, I'm going to say finish. Now you can see that it also tagged it, the name of the column. You could rename this to C1 or C2 or whatever you want, and it will display as that. If you don't want that, you had an option to cancel that, which I didn't do it. So it came with a tag here. The name of the column is also automatically displaying. So I'm going to say finish. Now, once you did that, all the columns are there. Now you can see in 3D view all the levels. I mean, it has come from lower level up to the last level. Now, if you want to put some beams, I will quickly do it again. So beam. So I'll go to second level because in first level we have foundations. At level 2 we have plinth. So I will take level 2 and then say beam, and you can choose your size. So I'm going to say concrete beam 300 by 600 for easiness. Same way, you can either do it on grids or you can draw one by one. It's up to you. So I'm going to choose on grids and select the grids and then finish. Now you can see that this time the tag didn't come because I hadn't chosen that. I didn't click on this tag on placement, so the tags has not come. If you want, you could do that. So this is how you model the beam. And if you want to replicate it into upper levels, you can do that also. That we will see later if you have time. So I have created the view. So to make it more neat, you can right click and then say hide in view by category. Everything got hidden. Then you have a center line here so that you can, I type VG, visibility graphics. Don't think that you can master Revit in a 1 hour session. It will take at least 1 month for you to master because there are a lot of basics in it. I'm just showing you what you can do. 1 hour session only give you an overview. You will have to just see and understand what it can do. Don't try to learn Revit in this session. It's not going to be really possible because I'm only showing you 1/100th of what Revit can do as of now because it needs a lot of time. It's a complete different from what we have been doing earlier. So analytical model categories, you can switch off the center line. Center line, in the sense, it is useful for importing into analysis tools. So a center line model is parallelly created, which we don't want now because we are only focusing on the drawing production as of now. So that went off, and here you can make it like realistic. So you can see a realistic view. So this looks a lot of cleaner, neater, and realistic. You can come here and then say shaded, it becomes a shaded view. You can have a hidden line, which is something else, consistent colors. So many options are there. You can have a realistic view. So this is a concrete finish, a material concrete finish you get here. So that's how you do that. Now we are having very less time. So what I will do is, I will quickly tell you, say sheeting. How do you put this into a sheet? So here I have an A1 metric sheet here now. So I'm taking that and you can bring and place it here. Now the neatness of this depends on what you have done here. So here you have a crop window. Now if you look at the sheet, you can see you have a neater look. Now the most beautiful reason that we should use Revit is the scaling automatically happens. All the dimension style, all this changes automatically in Revit. There is no need for you to change the dimension style and all that. So if you want to change the scale of the drawing, it's as good as this. In AutoCAD, it's a pain. You will have to then adjust the dimension styles and things like that. Here, nothing is a problem. It will automatically change the scale and your drawing looks much bigger here because the scaling has been done. You can just move it and place it. So that's the beauty. In the drawing sheet, it will auto adjust all the dimension style, everything will adjust itself. The same way, I will do one more sheet. And this time I'm going to put the section that we had. I think we had not made a section, so 1 second. So I'll make a section here now, just a section. And I'm putting that section into that particular drawing. So it will automatically do the scaling there, everything automatically. It's a section, first section in that particular drawing, all that. The fine tuning you will have to do, the stretching of the grids and things like that, you will have to do in the normal view. So that's how you can easily do the sheeting. There is no need of changing the dimension style or section reference or anything like that. It will automatically pick it. So that's the beauty of Revit. So this way, the revision control, everything will be quite faster. And rebar detailing, all that you can do, but we are really short of time, so I will not be able to show you the rebar detailing. All that can be done in the beams or even in the footings. You can model footings and do the rebar detailing. All that can be done, but we'll have to do it in a different session. So basically, the main advantage of Revit is its parametric behavior, wherein it automatically produces the sections and the changes reflected there, and the coordination part, work sharing part, and the sheeting revision control will be much faster. Oh, I think we have time till 6:30, right? I was thinking it is 6. So sorry, we have time. So I will show you a bit more. I was
Yes, sir,
thinking
we
that,
have up to 6:30.
yeah, I was thinking it is 6. I think I made a mistake in the assessment. Yeah, so we have time. So I'll show you a bit more. So coming to level 1, I will cut one more section. Now see, there is a difference between this and this. Here it is naming 1. Here there is no name. The same way, the reason is that this you have put in a sheet, so it is referring to that. Whereas here, this section you have not put it in a sheet, so it is not referring anything. So by default, by automatic placement in the sheet, it is referring to that particular thing. Again, see, you can control the range. It's very easy. Say you produce this section and this beam was visible in that section. Now, someone tells you that no, you don't want to, he don't want to see this beam. They say architect wanted to have a section without the beam visible. It's a matter of pulling it back. Yeah, so it allows you to change the location of the section. You can flip the section. All this can be done at the click of a button. In AutoCAD, you will have to do a lot of circles. You have to move it, you have to mirror it, then go and change the drawn section. Here, it's at the click of a button. You click here, the orientation of your view changes. It's as simple as that. Yeah, the range also you can adjust. So if you want, you can see that particular section. I forgot the number, section 2. Now you can see the plinth beam in this particular section. Yeah, but when you go here, and if you pull this back, actually double clicking here will take you, yeah, so you can see that this beam is not there. Yeah, so you can control that sectional view by doing that. So let me come to level 1, and yeah, so this is your level 2, in fact, the plinth level, and level 1 is your foundation level. Now, if you come here, even in level 1, you can see that plinth beam. So if you don't want to see that particular plinth beam in level 1, which is the foundation level, you can go to the properties of that view. Now, when you click here in this white area, whatever properties you are seeing, this is called properties palette. So whatever you are seeing here is the property of this view. So here, if you see, there will be a view range. Again, it will be confusing for you since it's the first time and I'm doing it a bit faster. But then there are a lot of concepts in Revit like this which will be confusing until and unless you systematically learn that. But once you learn, your process is going to be at the click of a button. So view range, you go and edit this. You can set your view range up to where you want. Yeah. So when I change that, the view range also from plinth level, it is only going 100 down from the plinth level. So it is not visible in the foundation level. So that way you can adjust the view. This is particularly useful when you are wanting to have a ceiling view and all that. Say you have a roof level as well as a ceiling level. In one drawing, you want to see the ceiling level, and in another drawing, you want to see the roof level. So if you want to do all that, this range options can be very much useful. Now here, isolated footing you can take, and it will ask you what size you want. You can choose or edit or change the size, but I'm now taking whatever is default. The same way at grids, and you can select all the columns and then say finish. You are done. Your foundations are ready. So once you are an expert, it's a matter of doing this. Now, you can also do a raft, you can also do a combined footing, but that needs a bit more time, or you will have to have that added in your template. So at the moment we don't have that, so I'm not showing that. Now you can see in 3D view that your foundations have come here. Now in case if you want a pedestal, all that can be done. It's not very difficult to do all that. You can, if you want a slope beam, all these are possible. Anything is possible in Revit. Only thing is that corresponding to the things that you want to do, you may need a little bit more time for that. Now let me cut a section here at the footing. Again, you can stretch in or out and then decide. If you keep here, your view range is up to here. If you keep it out, it will be outside. If you want the column to be seen, you can, I mean, if you don't want the column to be seen, you can show like this. If you want to see the column, you can do it like this or like this. And this is your section. If you don't want to see this particular box, you can hide crop region. Now, say if you want to put it into a sheet, you can either put in the same sheet that you have here. If you think that this is too small for this is too small, right? So you can change the scale here, say 1:20. Now see, it automatically adjusted all the grid size. In AutoCAD, it will never do this. You will have to change the style of this. So if you come here, see, it has automatically adjusted the scaling. You can do this. So any scale is automatically changed, and you can do that quite fast. Now even the dimension, I can show you that. So now say I do a dimension here, so I can go here, align dimension, and say I put a dimension here. Now let us go and check how it looks in the section. It looks neat. The moment you make the scale different, oh, this is not the sheet view. I'll now say I change the scale to say 1:50, and then so it automatically scales here. So there is no need of dimension style change here. All the arrow mark, everything will automatically populate to the scale that we have chosen. In AutoCAD, we have to change the style to make it properly visible. So that pane is not here. It works automatic. Now, in case if you want to put rebars, I will just quickly show you rebarring. So say I'll select the footing, and in structures, you can see rebar. Click on that. it automatically populates the different Riva shapes here. So I'm going to use this particular shape. It's a U-bar. So it automatically picks the cover there. So you cannot go down the cover. You can see a limit. That cover you can set whatever you want, 50 mm or 40 mm, whatever is as per your standards, you can set it. And it will not go beyond that. So you can see that it stops at that point. It doesn't go down. It goes up, but it doesn't go down. So a minimum cover is specified. So I'm going to keep it there. Yeah. And your diameter, I'm clicking on that rebar again. See, on the properties palette, the diameter is seen. Now, unfortunately, okay, you have, this is 10 T is Indian standards. So if you want 10 diameter, you can change it right now. It becomes 10 diameter. If you want 12 diameter, make it 12 diameter, that's it. So whatever diameter you want, you can quickly select and change. Now, why is it important? In AutoCAD, it's not important at all, but then in Revit, it's important because you are going to quantify it. Yeah, you can do that. Now, if you want to move it in this manner, it's very easy. You can do that. You can do this. Now, click on this and you can decide how many numbers, fixed numbers or maximum spacing or number with spacing, whatever you want to. So I'm going to choose maximum spacing because now it's only one bar that we have spaced, placed. I'm going to say maximum spacing and then say my spacing is say 100 or 200. So now you have 10 at 200 in that particular footing. If you want to see that, go to 3D view. Now, since it is a realistic view, you will not be able to see that. You have an option to see, make it visible, but then I will show it later. So wireframe, if you go, you can see this particular footing, we have placed that particular direction bar. The other direction bar, you have to place it. So we will do that. So coming back to, it was section 2, I guess. No. Yeah, so the other direction bar, what you can do is you again click on the footing, then go to rebar. Which shape you want the same shape. But the only difference is the placement. You have option parallel to work plane, parallel to cover, perpendicular to cover. So I'm going to choose perpendicular to cover. Now you can see that it came, a U-bar came perpendicular to cover. So I'm going to place it somewhere here. I'm selecting that. Same thing. I'm going to say I want maximum spacing. So in that direction, you should have designed it and whatever it comes. So if it is 200, give it as 200. Now it is coming slightly out. So what you do is click on this. I'm using the arrow key in my laptop and I'm slightly, or you can use this and then put it into place. Yeah, so you have both direction rebars. If you want to see that in 3D, you can see that both direction rebars are placed. Which layer is first, which layer is second, you can decide all that based on your design, short span first or long span first. Generally, the footing cantilevers will be same, so your moments on in both directions should be same as long as you are able to achieve that. So whichever is first layer doesn't matter. But still, if you have any preference, you can do that as well. So that's how you do rebar detailing. It's very easy to produce design intent drawings, but then if you want to create bar bending schedules, it's a little difficult in Revit for difficult beams. Say you have a column where 4 beams are entering in all directions, then some of the rebars may have to be cranked and taken and all that. You can do it, but then there are better tools which can do that purely for detailing and producing bar bending schedules. But still, Revit can do, say, as per Indian standards, whatever basic detailing you want, it can very well do 100% accurate. So that's how you do. I just showed you in footings. The same way you can do it for beams and columns and whatever you want to. Yeah, it's not a big deal to do that. And all the dowel bars, if you want to give a starter bar for your columns, all that similarly, you have to choose the right shape and then do it accordingly. Now, another main advantage of Revit is, see, in conventional system, in CAD platform, I hope if you understand how an office works. So this is a project folder that I have here. Say, if I have, say, one particular client, I have named the client's architect's name here, and then based on the project, say I have incoming drawings, and I'm listing out the dates here. The incoming drawing, received dates. The same way, I have an outgoing folder where I have named the outgoing drawings and the folder. So on 19th of March, I have sent these drawings. On 22nd, I have sent the scope and things like that. On 2019, I have sent the center line and things like that. So I have to save the drawings in a dated folder like this. Now, if you see here, I have sent the first, or say, center line drawing on this particular date. Now I might have sent it again as a revision, or say foundation layout P1 was sent on 3rd of that month, and then on 8th I have maybe sent a revision. Now how do I know which is the final drawing and in which folder is the final drawing? I will have to keep a transmittal or a Excel sheet where I write down that this particular drawing was sent on, say, footing layout was sent on one particular date. The first drawing went on, say, 10th of this month. The second revision went on, say, 15th of this month. So and so I have to write down so that I clearly understand where is the latest drawing. The same way, I have to save this in a dated folder as well. So now two mistakes can happen. One is that I missed to write in the transmittal, which is the final drawing, send date. I can also miss to save that here. So two mistakes can happen, and then either you will struggle to find the final drawing, or you will have issue, you will forget, or you will not even realize that there was a newer drawing than what you think is the latest one. So these kind of mistakes will never happen in Revit, simply because your every drawing is here listed, S1, S2, S3, and even if you revise here, it will be there as the latest drawing. I will not have time to get into the revision control in Revit. It's quite fantastic. Revision control in Revit is one of the best. It will never let you pick an old drawing. It will always flag up. It will never let you take a old drawing. So if you have S1 revised 10 times, it will only let you take the latest drawing. If you purposely want to take an old drawing, you can, but by mistake, it will never let you take a old drawing. So that way you are always on the safer side. And every drawing, if you have 100 drawings in a project, everything is in one file. In AutoCAD, you cannot save every drawing in one file because it gets heavy and then you will have all kind of issues. Here, if you have 100 drawings in a project, every 100 drawings will be in one single file. So your control or ability to control the drawing, or to save the drawing, or to carry the drawing, everything will be easy. You need not struggle to find the latest drawing and things like that. Then coming to work sharing and the other aspects like collaboration, we have no time today, and we don't have a networked machine. Then only I can show you that quite well, wherein two models are interlinked and the changes done in one model getting reflected in the other one. All that we will not be able to do that today, so I will skip that, and I will just tell you, as I think all of you are teaching in polytechnics, and why it is very much important for you and your students to understand Revit or migrate to Revit. First thing is, in the current scenario, remote working is getting really important. And if you are aware, many of the consultants, I'm a part of Kochi Consulting Association. I'm a member in Kochi Consulting Association as well. So many of us are looking at pooling resources or work from home options, wherein multiple CAD technicians are going to work for multiple consultants. So I'm thinking that the way that we are going to work is going to completely change, at least for some time, because uh, the number of projects, the demand, everything is changing. So there is going to be a change in the way people are going to work as well, as per my understanding. So there will be a lot of remote working possible. One person may be able to work for multiple consultants, part-time kind of work. There will be opportunities to outsource work. All these are going to increase in many fold. So remote working is going to be really important, and your ability to adapt to that is going to be really important. And Revit is a tool that allows doing that. And then it comes to a quick way of producing drawing. You can, if you are a master in BIM tools, you can produce your drawing quite fast. And as I showed you now, the revisions are going to be really fast, super fast. So if an architect makes a change, it doesn't take that much time as you used to take in AutoCAD to make the revisions. It will be much faster in Revit. And the mistakes are going to be much lesser. And you get a coordinate drawing because you are going to also interlink the drawing, the models between disciplines. So the kind of mistakes that you are going to get is really going to be less. So you get a well coordinated drawing first shot. You need not coordinate sitting in offices, and in the conventional way, you may not have to coordinate anymore if you are doing it perfectly. But one requirement is there, that is, every discipline should work on the same system in Revit. Then only that benefit can be made use of. Otherwise, it will be like independently one discipline working on Revit may not reward you as much as all disciplines working on the same platform. But still, it will be useful. Then already. You know that there are a lot of places which uses pre-cut bars. Now, the number of migrant laborers, they are very much less now in all the cities, especially Kerala is going to have a lot of issues with that. So cutting and bending at site is going to be much lesser. So people are definitely going to be preferring pre-cut bars. So bar bending schedules are going to be a real requirement. I hope you understand what is a pre-cut bar. Say, for example, say in the same footing that we did, we wanted a U-bar. Now, inside you will, a basic estimation of quantities goes into any project, but then you are not estimating what is the exact length needed, what is the exact length needed for the legs. All these you are not estimating. Now, what if this leg is deeper or longer than the depth of the footing? Then at side you can cut it. But if you are ordering a pre-cut bars, you want to get precise dimensions, maybe a tolerance of 5 mm, not more than that. So you need to estimate, or you need to produce bar bending schedule which states the a dimension, this dimension, accounting the turning radius, what is the total dimension of the rebar. So if you produce this bar bending schedules, there are really good factories. The one I know is in Bellary in Karnataka, North Karnataka. JSW have a really nice factory which precisely cut and tag and deliver the rebars at site. So that's going to be popular in every part of the world. Bangalore already uses a lot of pre-cut bars. Major projects I'm talking about. Smaller projects might continue in the normal way for some more time, but then when resources are not there, when manpower is not there, definitely more people are going to migrate into this system where you deliver pre-cut bars to site. Definitely this is going to be the time when bar bending schedules and these are going to be in greater demand. So these kind of work, people who have the skill is also going to be required to deliver these bar bending schedules. So these schedules go into the factory. it's fed into their system, and precisely cut bars are produced and tagged and delivered at sites. So it should be a precise bar bending schedule. So all engineers graduating from polytechnics can look into this kind of work. Already there are a lot of students or people working in MNCs doing this job in Bangalore, Noida and all that. I'm not sure about, I think even in Kochi, I have a friend or a senior in college who is doing that business. So it can become a kind of business for people who are masters in bar bending schedule preparation. A lot of firms like Atkins or WS Atkins, if you know them, and ACOM, they outsource these bar bending schedule preparation to India, because the skill that they have in Middle East or in UK is lesser compared to what we have here, and such kind of job which needs some patience, they generally outsource. So these kind of jobs are really in need, and a lot of young CAD engineers have become entrepreneurs, and they are leading a really good work-life balance as well. So these kind of things help students to get into a better lifestyle and better job nature than compared to a normal draftsman or a site engineer, because it allows them to have more revenue, more interesting tools they are using, and it all shows up in the end. So bar bending schedule preparation is a really good field which most of the CAD engineers can explore. Then of course there will be a lot of opportunities in Revit, building information modeling as such, in all disciplines. So these are all really going to be the future. If you look at many universities abroad, there are now courses in BIM. It may not be Revit alone. They will teach you a lot of BIM tools, and you be a BIM master. You will be leading the BIM in MNC. So that also these young students who are passing, graduating from polytechnics can become CAD engineers. Instead of CAD engineers, they can be BIM modelers and BIM technicians and modelers and managers. These are all evolving roles in most of the modern companies, MNCs. So introducing them to BIM is going to be a help for all the students.
Hello, sir. We have a few questions, sir.
Yeah, so I think I will wind up here. If you have any questions, you can ask me. Yeah. Now I can hear. Yeah, tell me.
Okay, sir. I'll start from the latest one.
Yeah.
Okay. One is what are the advantages of using Revit compared to Tekla?
Okay. Okay. See, Tekla conventionally has been more used for say steel, but current versions of Tekla, they have a great CADing and bar bending schedule preparation tools are there. But when it comes to the global usage, Revit scores a lot better, especially because most of the architects are using Revit. And for GA production, Revit is much better than Tekla.
Okay, sir. Sir, another question is that can you
Yeah.
show us a completed drawing of any building done with Revit?
The problem is I'm stuck in Kerala here now. So my main laptop and everything is in Bangalore. So whatever I have, I will try to show you. Okay, this I did in the morning just for showing you. Yeah, so this is a footing layout. And so you can produce 3D details like this. This is a footing drawing. You can tag your beam details and show up like this. It can be more precise. This is done very fast. So the style, all that you can change. This is 12 diameter. This is 12 diameter, 2 numbers. This is the name of the rebar. So if you want to hide the name of the rebar, all that you can do. So this will be the beam detail, like roughly. It can be much more neater.
Okay.
Any other question?
Yes, sir. Another question. Do we need to analyze the structure elsewhere and bring in the result to Revit for modeling?
Yeah, see, you can do that, and the best software which is compatible with Revit is Robot. Robot was a independent company in UK, but then bought over by Autodesk, and both are now Autodesk products. So obviously, they are more compatible. And etabs also has a plugin which you have to separately buy from CSI, which will allow you to integrate. But then as a structural engineer, you need to think if you really have to integrate or not, because what are you going to gain by doing that? Especially when it is an RC building project, you are not going to gain much by integrating etabs and analysis tool and Revit, because it's a member size that will be imported and exported each other. Rebar, etabs is not going to export or import, because etabs is not good at producing that. So it will not import all that. So you will still have work to do after importing into Revit, even if you are doing that. So basically you are only importing the member size upgrades. Say you modeled 300 by 450 beam in Revit and then took it into say etabs and then did the analysis. Etabs, after design, you realize that the size of the beam has to be 600. Then you are bringing it back. But that's a pain. Rather than that, you can change the size in Revit itself. It doesn't take much time to change the size. Now, why I'm saying it's a pain is, see, as an analysis or design engineer, you know that, say, a minor change in your location of the column, say 200 millimeter, your column changed. It's not going to affect your analysis. Say you have a sunken slab in your project. It's not going to change the load in your project much. But then if you have to incorporate this interlink between Revit and etabs, every minor change in your project will have to go into that. So if you have a sunken slab, you have to do that even in etabs. If architect moves the column by 100 mm, you have to change in Revit as well as in etabs. Yeah, so that unnecessary change, say 100 mm change in etabs model is not going to change analysis by any margin. Yeah, drawing has to change, but the analysis need not change. So only for that reason you may have to do this import export multiple times unnecessarily. Yeah, so what I have seen is for many projects you will not need that feature of interconnectivity.
Okay. Sir, is there any scope for file conversion in Revit?
Yeah, you can convert that into PDF, or you can print an AutoCAD or whatever you want.
Okay, can we relate that with any estimation software and
Revit by itself will produce quantities. I didn't show you that, but it can do it.
okay. Okay, so then another question we have, what are the advantages of using Revit compared to Google SketchUp?
See, I'm not really what you call competent to answer that, because I'm not an architect. Google SketchUp is completely a visualization, modeling, and what you call architectural purpose software. It's limited to that. Yeah, but then when it comes to Revit, it is BIM. Google SketchUp is not yet BIM. It's just a visualization 3D software. Maybe you can do a bit of architecture in that. You can. They have improved Google SketchUp now. You know that Tremble has taken over. I hope you know it. SketchUp is no more Google SketchUp. It is owned by the Tekla company. So they have brought in a lot of changes in that, and due to that, it's much more better. So it can create 3D visualization, it can create interiors, it can create a model for architects, but it doesn't have this BIM property.
Then can we make an irregular section?
Yes,
Yeah.
anything can be done. See, there are two ways of working on that. one is borrowing it from an architectural model. So if an architect has already taken the, you are asking as a in a structural perspective or in an architectural perspective. If you are an architect, yes, you have to make it. If you are a structural engineer or any other consultant, you can always borrow what he has done. So it depends.
Okay.
And if you want a star-shaped column, you have to create I told you about the hierarchy, like the family files and all that. Yeah, so Revit gives you standard family files. Say if you have T columns, Revit may give you, but if you have a star shaped column, it's a unique column for you, so that you will have to create a family file for that, or borrow from someone who has already done that, or there are many companies who sells this family file. So if you have a complicated member shape, you may have to either make it, or you will have to buy it, or you have to borrow it, things like that.
Okay. Okay, sir. Thank you for this particular session and information. And I will quickly pass on the mic to Ms. Gayatri of Sri Rama Polytechnic for giving a feedback about the session.
Yeah, thank you.
Good evening, all. Sir, this was very informative and interesting session. As we all know, it is not possible to learn the Revit software in just 90 minutes, but still, you could able to convey the basics, importance of the software, a little bit of micro and macro features of this software within this short time. Thank you so much, sir. On behalf of all the participants, I express my sincere gratitude, sir.
Yeah, thank you to you too for giving me this opportunity to interact with you all. It was a nice session for me too, a good experience as well. Thank you. And in case if you have any further questions, you can always email me.